Hello grade 11s. We're just going to do a little video of sketching hyperbola for you. I'm going to do a little bit of the initial theory in general and then give you 2 examples from your exercise 4 in your textbook. Okay, so if we look at the theory, we've got our standard equation of any hyperbola over here, y equals a over x plus p plus q. Now, the first thing to take note of is this plus q, and that plus q always indicates whether the hyperbola shifts up or shifts down. So that really would indicate always your horizontal asymptote. Remember, an asymptote is a line that the graph gets closer and closer and closer to, but never touches, never crosses. Then we also have your a, which is always on the top here. And what we're interested in with the a is either whether it's positive or negative. So if the a is positive, then my hyperbola is in quadrants 1 and 3. And if it's negative, then it's in quadrants 2 and 3. So it's just a case of remembering all these things and how they affect the look of the graph. And then the third thing, or the third fact, is this plus p here, which is because it messes with the x, because it affects the x, it's going to be a shift along the x-axis because it's x plus p or x minus p. If it's plus p, it's in a negative direction. And if it's minus p, it moves the graph in a positive direction. Okay, so let's look at an example together now. So the example we're going to do together is y equals 6 over x minus 2 plus 3. So the first thing is this plus 3. Now that is a shift up of 3 units. So my asymptote is going to be over here at y equals 3. Then we've got the a's value is 6, which is greater than 0. So it's in quadrants 1 and quadrant 3. Then at the bottom here we have x minus 2. Now remember, that's a shift in the opposite. So if it's a minus 2, it's a shift to the right in the positive direction. So here, if we look at the green, it's a shift right of 2 units, which indicates then my vertical asymptote, which will have the formula x equals 2. Then the next thing, let's go look here. So far, we've got our horizontal asymptote, which is a shift up. So it's y equals 3. And we've also got the vertical asymptote x equals 2. And we also know that the hyperbola is going to lie in that quadrant and that quadrant. We just don't know what the x-intercept and the y-intercept is going to be. So now we need to go and find it. So to find our x-intercept, we make y equals 0. So in place of y, we put 0. And then let's work this out. So we first take the 3 across and we get minus 3. And then remember, we need to take this and multiply it by the other side. So we're going to have minus 3x plus 6 equals 6. Minus 3x equals 0, so x equals 0. Let's hope that's right. And now we're going, so let's write that though, excuse me, as a point. So it's going to be 0, 0. And the second thing here is to find the y-intercept. So we make x 0. So we're going to have y equals 6 over 0 minus 2 plus 3, which looks like it's also going to be 0. That's interesting. So that would mean that my x and my y-intercept is also going to be 0, 0. So now we need to do the final sketch. Let's do it in a different color. So my horizontal asymptote was y equals 3. My vertical asymptote was x equals 2. Let's draw that. So now when you go and you sketch it, the first thing you do is you always put in your asymptote. So that's 3. Remember, it would be 0, 3. We always write it as a point with an x and a y coordinate. My vertical asymptote is going to be over here. So that's going to be 2, 0. It's also a useful exercise to actually write on the equations of the asymptotes because they always end up asking it. So we just put it on there. And then we found out that the x-intercept was 0 and the y-intercept was also 0. So we write that as a coordinate point, 0 to 0. And then we make it as nice and neatly as we can, kind of heading towards the asymptotes. And then we do the same over here. There we go with the arrows on the end. Don't forget to also label your graph y equals 6 over x minus 2 plus 3. Okay, that's not so bad at all, is it? I don't think so. Okay, let's do another one, example 2. So this time we've got y equals 2 over 1 minus x minus 1. Now, if we look at our standard form, which is y equals a over x plus p plus q, this isn't really in the form that I wanted with the x first. So what we're going to do is we're going to rearrange it using our knowledge of algebra to make it look like our standard equation for hyperbola. So this 1 minus x, what I've done here is I've taken out the minus. I haven't changed its value, I've just taken it out, because if we check, minus times x is minus x, there it is, and minus times minus 1 is plus 1, which is there. So I haven't changed its value, I've just rearranged what it looks like. And then that minus, in the next step, I just took it and put it on the top. Because remember, when you deal with a fraction, the minus can go at the part of the numerator, the denominator, or in the middle. Now we've got it in standard form, we can have a look at sketching. So this minus 1 is a shift down, and it brings in the y asymptote, which is going to be y equals minus 1. Then we have a look at this here, x minus 1. Remember, it's in the opposite direction, so it's going to move that way. So that means my x asymptote, or my vertical asymptote, will be x equals 1. And this minus over here indicates, because it's a negative, my hyperbola's branches or arms are going to be in those two quadrants. So now if we do a little rough sketch, I'm just going to do it here. So in your head you can picture what it looks like. So y equals minus 1 is there. Remember, we like to write it in. X equals 1 is there. Cutting it 1, cutting it minus 1. Write it as a coordinate pair. And then I'm going to have it here and here somewhere. We have no idea where it cuts yet, so that's why we lead on to our next step, which is to find the x and the y-intercept. So the x-intercept, we make y0. I'm going to work with original, it doesn't really matter. Take the 1 across, times through. So minus x equals 2 minus 1, which is 1. Okay, so that's going to be your x-intercept. Then the y-intercept, we make x0. Okay, so let's go and sketch this now. We've kind of already drawn the axes. So let's have a look. So we've got y equals minus 1. So that's my horizontal asymptote. Y equals minus 1. Fill that in. Let's remind ourselves what the vertical asymptote was. It was 1, so we go back and we fill that in. Doesn't have to be exact, but we need to kind of do it as much to scale as we can. This is going to be 1, 0, and this equation will be x equals 1. Now our x-intercept was minus 1, 0. So on the x-axis, it's going to cut there. And let's draw it as neatly as we can. Oh, I forgot to look where the y-intercept was. Sorry. Our y-intercept is 0, 1. Okay, so there's a whole lot of 1s involved here. So we've drawn it, that was 0, 1. So there's that branch drawn. Now we go and we draw it as neatly as we can here. This branch here. Okay, don't forget to label it. Y equals 2 over 1 minus x minus 1. And there you have it. There we've drawn our two hyperbola. Just to end off quickly, I want to make a comment about your axes of symmetry. Remember, an axis of symmetry is something that divides your sketch exactly in half. So that's a mirror image. So if we had the parabola axis of symmetry, it would be there, dividing the parabola in half. So your axis of symmetry for your hyperbola is going to be a straight line there. Because if you can picture it, if I took this branch here and this branch here, and I kind of folded the paper over this purple line, it would fall on top of the other branch or arm. It's like it divides it in half, if I can put that way. It's an axis of symmetry. Now, it always goes through that point there. So that point is crucial in finding the equation of this straight line, which is y equals mx plus c. So this point here, 1 minus 1, is crucial. And the other thing that is important to remember, it always has the gradient of 1. Always, 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 because it always goes at a slope like this. But that is not the only axis of symmetry. There's another axis of symmetry which goes in this direction, right? Because this arm here would fall exactly on top of this arm here if I folded it over that orange line, that axis of symmetry. And this axis of symmetry has the equation also of a straight line, y equals mx plus c, but the gradient is always minus 1. Always, always, always. The only thing you need to find is c, and remember we find it by subbing in this crucial point here, 1 minus 1, where the two asymptotes cut each other. Okay, grade 11s, I hope that's very useful. So off you go now to draw some more and also work backwards to find the equation once you've got certain information. Thank you.